Hello, we are MTR.
I'm Mitchell Padilla from Section A21.
I'm Tony Zhang from Section A22.
I'm Roger Sung from Section A22.
So this is the second project of Engineering 6, and what we're going to do is take an NDVI image and analyze its data to determine how much vines should be irrigated.
We will run our code through our GUI. So we run our code and we load the image file, .tif NDVI image, into the GUI. It comes up, and first the user is prompted to click 2 points, making a line along the axis that we want to become horizontal. And the user is then prompted to crop around the region of interest to isolate it. And after that, the user is prompted to click on the upper and lower bounds of the region of interest and the left and right bounds of the region of interest. This lays down a grid, and using the points of intersection of the grid that we have laid down, it puts our information into, and we get the row number, the vine number, and in columns 1 and 2, and then in column 3 we have the weighted irrigation times.
This is Roger Sung, and I will be explaining tasks 1 through 4. So in this first line, the UI get file will prompt the user to pick a file, and IMRead will read that file, and we label that as A. IMShow will display that image. Set will show the user to click 2 points to rotate the picture, and we do so by using the G input function. Theta is our angle in which the picture will be rotated about, and we use the arc sign of A1 and A2, which is essentially a horizontal line, and we divide that by the hypotenuse. And here B equals imRotate, so the function imRotate will rotate the picture along with theta. This set function will tell the user to drag a rectangle to crop the picture, and imShow will display the rotated picture. B2 equals imCrop function, so that this function will actually crop the picture, and imShow will display the cropped image.
This is Mitchell Padilla, and I will be explaining how task 5 was accomplished, which includes laying down the grid onto the image in our GUI. So I used a G-input function of 2 points, which allows the user in the GUI to click 2 points, and it stores the x and y values in the variables c and d. X for c and y for d. And I took the difference of the d values, which is the y values, because first the user is prompted to click the top and bottom bounds of the region of interest, and so that there is a change in y values. That is important, and I store that in E. And so I have the total distance from bottom to top of the region of interest divided by 39 to get the desired 40 different rows, and that step size of the rows is then stored in F. And after that, the user is prompted through another G input function to select another 2 points of the left and right bounds of the region of interest, and those x and y values are stored in G and H. And I then want the difference in the G values, or x values, because the user clicks the left and right bounds, which means there will be a change in x to know the distance of x of the region of interest, and that's stored in I. And to get the step size of the vines, I know that there are 6 feet between the rows, so I multiply that by the variable f, which is the step size of the rows, and then divide that by the distance between the vines, which is 8, and that will give me the step size of the vines, knowing that ratio. And then after getting these values, to lay down the grid, I store m as the size of the image, which we call B2, the cropped image, and then n is the size of B2 with x and y. And I use a for loop to go from the first y value that I stored in the g input function to the upper bound using using a step size of f, which I calculated above. And then x is from 1 to n, the size of B2, and then y is for the from the lower bound to the upper bound with the step size of f. So that creates the rows, the horizontal axes of the grid. And I plot x and y with a desired detailing of the lines on the grid. And then I use another for loop for the vertical rows. So I use the left and right bounds, the x values differing from the g input function, and the step size of the vines, because that corresponds to the changes along x, which will give vertical grid lines. And so then for x, I have used the function or the bounds of k, and y is the total size of B2. And then I plot those x and y values, and using the same type of grid lines to make it consistent. And I unhold the image to lay the grid.
Hi, my name is Tony, and I'll be explaining tasks 6 through 8. So we start off by initializing the row number, which we increment each time we run through this loop. And then t will be the minimum value of B2, u will be the maximum value of B2, and these two variables we'll be using in this line right here. Before we get there, what this matrix is going to be the x-coordinate of the intersection of the grid and the y-coordinate of the intersection of the grid. And this will be the pixel value at that point. What this line does is it will scale the minimum of B2 and the maximum of B2 to a number between 240 and 480. And this block of code will create the actual output that the user sees at the end. In the first column, it'll be the row number. Second column will be the vine number. And the third column will be what we just calculated above, the irrigation times. And finally, our program will spit out the text document of actual output, which was this matrix right here.